So we're going to put together a little bit of a preview of what a note card could start to look like for the summative that we will have at the end of this polynomial unit. So I'd like you to kind of follow along and fill in some of this as we go, and you can decide at the end of the unit whether you want to transfer some of those onto your note card or not. So we began the unit with our polynomials and adding and subtracting polynomials. So recall when we were doing this, that we were really thinking about combining like terms. And remember, like terms, we won't use that. Combining like terms meant that we were putting together any terms that had the same variable and the same exponent. So same variable and same exponent. That's what like terms are. And then also remembering that the negative in a subtraction goes to each term. Kind of like a distributive property with a -1 here. So you notice the example that we have shown here is a subtraction problem with polynomials. So this negative, this subtraction, is kind of like a negative that is subtracting each one of these terms. And so we need to be thinking about, well, really, let's think of this as a minus. I'm going to change this to a plus, and then the minus goes to this term, the minus goes to this term, and the minus goes to the last term. Now, all of the terms happen to be positive to start, so subtracting them doesn't really cancel out a negative and make a positive. It means that we are subtracting each one of those terms. So let's now combine our like terms together. So thinking about combining our 3x squared minus x squared, so that would be 2x squared. And then combining our x terms here, we have 4x minus 6x, so that would be a minus 2x, 4x minus 6x, or plus -6x. And then we also have a -7 plus a -1. So think of that as like a -7 minus 1, which would be a total of a -8. So our new polynomial, when we combine our like terms together, ends up being 2x squared minus 2x minus 8. Now, if we had been adding all the way across and we didn't have the subtraction sign, that makes it just a little bit easier. But always be thinking about what are your same variables with the same exponents. You might want to use a little either color, it's easier for me with the color, or maybe a little symbol like a star underneath each like term, or an underline or a circle, so that you can put together the like terms. So that's when you're adding and subtracting, is you are combining those like terms, and essentially you're combining the coefficients and keeping the same variable. Then we moved on to monomial multiplication. In other words, we had to multiply a one term times a two term or times a multiple term polynomial. But in that case, what we're doing is we're using the distributive property. So use the distributive property. And also, I would say use exponent rules when multiplying. So recall from last unit when we were using our multiplication rules for exponents. And sometimes in addition to that, you might have to combine some like terms together, so going back to the first one. But we have a little distributive property here. And so we've got 4h squared times 5h, and then 4h squared times 3. So when we multiply, let's multiply the coefficients. 4 times 5 is 20. And then h squared times h, in other words, h squared times h to the 1, would be h to the third. So 20h to the third